Hi, good afternoon. My name is Maria Pantoja. I work for the Computer Science Department at CalPoly in San Luis Obispo. And I'm here to present a project that I have in collaboration with two agricultural departments. One is in California with my own university, and the other department, it actually is in Chile. We have 12 months of work, completely different weathers and so on. Anyway, so this work has actually been supported by the Agricultural Research Institute in California. So this is a problem. Traditional, and it's related to wine jars, so it's the dream of every computer scientist, apparently, to work with the wine industry. This one is, for hundreds of years, the viticulturists have been trying to increase the quality of the grapes. They will sacrifice production anytime, if it's necessary. What they want is the quality. And to evaluate the quality of the plant, the quality of the grape, they do it actually as soon as possible on the plant. And what they do is that they actually weight the canes of the new growth of the plant. So everything that the plant has been producing 1 year, in the last year, they cut it, they weight it, and then they compare that number with the production, the grape production. So it's as you can see, it's a very, very manual process, and therefore they can only do it for a couple of plants per area, for a certain area. And therefore they lose a lot of variability. So this is the project. In summary, everything that I wanted to really say is actually here. The project is to build an app so the viticulturist or the farmer can actually just go into, when it goes to the wine jar, it will take a picture, and directly by taking the picture, we can do segmentation. Obviously, we don't need to weight anything, so it will take a picture. We do segmentation on the vine, and we actually calculate the weight. Because we have the geolocation, whenever we take the pictures, then we will do that nice map that is in there. It's actually the map that represents the variability in the farm. And that map is an indication to the farmers, not to the farm, well, yes, to the farmers, of how they should actually prune the wine trees and to attach, they call it the canopy, how to create the canopy and how to actually prune the plant. So obviously, actually creating the maps, we have no problem. Doing the Rabat's index, manually doing the index is actually also very easy. It's only that it's very, very expensive. So the only thing, in theory, that I need to do is actually to do that segmentation, to do that application that actually, just by taking the picture, it does evaluate the weight of the canes. So the biggest problem is that it has to have, it's not just a rough segmentation, it has to be a fine one, right? So we need to subtract the background, because what we are going to have, this plant is because right now in California all the wine trees are full in bloom, right? So I cannot show you the canes. But the problem is that when you take the pictures, because of the lines are one after another, then we have one tree and immediately the one behind, right? But so subtracting the background is our biggest problem. So we are going to use the depth map to actually be able to do this subtraction. And right now what I'm doing is with my normal camera, and I have an iPhone. I just bought an iPhone so I can actually use that disparity map and have easy access to the depth information, but it can be anything, any phone that has dual cameras. What I do with the camera is that because they give you access to the depth map, then with that I create what is called a tri-map, and a tri-map is dividing the image in between 3 types of pixels. It can be, in my case, the plant, the background, or the edge. It's because it's the edges where every segmentation algorithm has more problem. But I'm creating in summary, what we are creating is the RGB and the tri-map. This is it's very bad slide, but it's what I use to my colleagues in the agricultural department to explain to them that every time that we develop a deep learning algorithm, it has 2 parts. So I have to do the training, and to do the training, I'm going to collect the data. So not only collect the images, is that I also need the manual data. So I need them to go through the entire process that they will do normally to actually gather the data. And then we will do the inference and validation. Because I actually need a fine-tuned segmentation, and because I'm actually evaluating the weight, so this is the steps on the implementation, and they are, and I've been talking to the farmers and all that, so this is what they want. They really want an app that, even if it just gather all the information and put it together, so they want to have that database and take pictures of all the trees that they have on their farm. And the only thing that I need is for them to take the image at a distance, and they don't want, so they want that distant measurement as part of the app. And then I'm using, it's only that I only have, right now I only have 200 images. I'm waiting, this month Chile is going to send me thousands of them, and then next year I will get the California ones. So the what I've been doing is testing different algorithms, and by far the one that works the best is what is called deep mating, which is segmentation, very fine segmentation, and is what the cameras Adobe and Apple uses for doing these portrait images, and then they completely take the background, but you can see your hair and so on. So I'm using that, and to use that, they actually use as an input the RGB and the tri-map. This is the result. So you can see the original image, how that it is a problem. That is, it's not that I need to detect the tree and where it's located on a rough estimation, is that I need the fine segmentation. So I'm getting, right now I'm getting the one, already the one on the right, although I'm super overfitting. My hope is that now that I get all my images, I will confirm that is actually, I can replicate that with images from here and there. And there is Chile, here is California. So this is my conclusion. The ag tech industry is booming. This is from Forbes magazine, and they spent $5 billion already last year, and they expect the growth to be exponential. There is a lot of money. They really need our expertise, and they are kind of amazed that we haven't contacted them already. So, what do I say there? Okay, so and now I'm nervous because this thing is ticking. So, anyway, so this is a project. It seems simple. It is simple, but it's incredibly useful for the local industry. I cannot tell you in enough stories about how happy the growers at San Luis Obispo, which is very rich in wine, are that we are actually giving them this app. And with that, I'm done, perfectly on time. Thank you.